Hey everybody, this is Mr. Piercy, and what we're going to be looking at in this lesson is kind of a recap video of an investigation that you would have done over 30, 60, 90 special right triangles. So this is a video that you're meant to kind of watch after you do the investigation. This is just to kind of follow up on any thoughts that you might have had, hopefully give you an opportunity to clear up any questions that you may have come up with as you did the investigation itself. But I'm going to go ahead and run through it here briefly, and you can kind of check what you put in on your investigation versus what I have here. But hopefully we were able to draw the correct conclusions about the two rules associated with 30, 60, 90 special right triangles. So the first thing it's telling you to do, it says in the lower left-hand corner, make a triangle. Where from the lower left-hand corner, I'm going to extend one space to the right, and I don't know why it's writing here. Let's try it again. There we go. So we draw a triangle here to the first horizontal and to the first vertical dot from the lower left corner. Now in part 2 it says the acute angle at the bottom is how many degrees, and what are the rest of the blanks here? Well, looking at this part here, we know that the angle at the bottom right is going to be 60 degrees because it's formed a part of an equilateral triangle, and that's kind of what you're seeing in the green triangle up at the top. In the box at the bottom of the dot paper, it essentially lets you know that the way the dot paper is set up is that it's meant to form equilateral triangles. So because every interior angle of a triangle, of an equilateral triangle, I should say, is 60 degrees, that's how I know that the bottom right-hand corner is 60 degrees, because it's essentially half of an equilateral triangle. So the remaining angle has to be 30 degrees. So part 3, now that we know that the diagonal and horizontal distances can be counted the same, what's the length of the short leg of the hypotenuse? Well, in this case, when I work it out, uh, the short leg of the hypotenuse, or the short leg is 1, the hypotenuse is 2, and that means we can use the Pythagorean theorem to find out what the length of the long leg would be. So when I use the Pythagorean theorem with the hypotenuse of 2 and a short leg of 1, I get the long leg to be the square root of 3 units long. A lot of students, when they have a tendency to do this, even though they visually they can see that the vertical length and the horizontal length are not the same, a lot of students still do have a tendency to say that that vertical length is 1 unit long because from dot to dot they're only counting in one segment. But the Pythagorean theorem in this case says, well, it's definitely not going to be 1 unit long. It's going to be the square root of 3 units long, which is the decimal value of that is greater than 1. So part 5, extend the vertical leg up one space and the horizontal leg right one space. And when we do, we wind up with kind of a figure that looks like this. Well, what's the length of the short leg and the short leg and the hypotenuse? Well, here all we're doing is extending the sides. So the length of the short leg will be 2 units long now, and the hypotenuse is 4 units long. And if one up and down segment is the square root of 3 units long, then the next one should be 2 square roots of 3 units long. Now part 6, I'm not having anything filled in here simply because you're supposed to make a prediction. What will the length of the long leg be if we extend it out a third time? So if you do extend it out a third time, we're going to wind up with something that looks like this. And when you do the Pythagorean theorem to find the length of the long leg of the third triangle, it will be 3 radical 3 units long. So essentially what we're doing here, the reason why we're constructing these triangles in the way that we are, is to establish a pattern of lengths compared of the lengths of two sides of a triangle compared to one side of the triangle, and that's what this table is going to kind of help us fill in. Well, when we fill in the table, we're going to see that when the short leg is 1, the hypotenuse is 2, and the length of the long leg was 3, and so on. So if we continued through the iterations, we would have a short leg eventually of 5 units long, a hypotenuse that would be 10 units long, and a long leg that would be 5 radical 3 units long. Now, filling in this next part here, problem part 8, I want you guys to understand part 8, this is the meat of the lesson. The two conjectures that you're supposed to write here are the whole purpose of the investigation itself. And a lot of times what I look at as a teacher is I want to see, well, how did you actually write how did you write this down? Because how you write this demonstrates your level of understanding. And that's one of the things that an AP style math class is expecting you to be able to do. Can you actually explain what you're seeing? Because at some point when you take an AP exam, you're going to have to be able to answer questions like this. And having, good thoughts, complete sentences, that really goes a long way for your evaluators to say, well, they really understand this or they don't. Okay, so here are my responses. Based on the data in the table, if I know the length of the short leg of a 30, 60, 90 right triangle, then the length of the hypotenuse will be twice as long, and the length of the long leg will be the length of the short leg multiplied by the square root of 3. So that's how I would write my conjectures based on what I'm seeing in the table. Now here are the two ways that I would take those conjectures and write them as a math statement, where I'm saying h for the hypotenuse is equal to whatever the short leg is times 2, and the long leg, that's what I'm saying LL, is equal to the short leg multiplied by the square root of 3. So I'm taking the two statements that I developed from seeing the patterns in the table, and now I'm converting those conjectures into a math statement that I can now use. Now pay attention, because the way that the equations are written based off of the statements, the short leg in both instances is the independent variable, and the hypotenuse and or the long leg are the dependent variables of the equations. That means when I'm looking at a 30, 60, 90 triangle, the key to it, to really be able to know what something is in the triangle, is the short leg. I have to know what the short leg is in order to be able to figure out what the hypotenuse or the long leg would happen to be. So test your conjecture. Okay, if the triangle is 5 units long, what would you have? Well, if you drew it out on your grid, you would say that according to the conjectures, I would say the hypotenuse is equal to the short leg times 2. So 5 times 2 says the hypotenuse would be 10 units long. And if the short leg is 5, well, I multiply that by the square root of 3, and I'd say that the long leg is 5 radical 3 units long. So the reason why we can say that we can put this final ratio here, x to 2x to x radical 3, that's because it is true for every 30, 60, 90 triangle. If I know the length of the short leg, I multiply it by 2 to get the hypotenuse, and I multiply it by the square root of 3 to get the length of the long leg. So just to kind of recap, this bit right here, those are the two rules that we're essentially going to be using anytime that we need to evaluate a 30, 60, 90 special right triangle. Now, just like what we saw with 45, 45, 90s, there's going to be a little bit of algebra applications that we'll have to use because the rule, particularly with the long leg, uses an irrational number or a square root of 3. We have to be able to rationalize the problems whenever we have a square root of something in the denominator of a fraction. But for the purposes of the investigation, those are the main points. Those are the key concepts that we need to understand. And these will be the rules that we'll use whenever we're evaluating 30, 60, 90 triangles. So if you have any questions about anything that you've seen in the investigation here and you're not quite sure about it, well, let me know. Send me an email, leave me a comment in the Google Classroom or something like that, and I'll be happy to answer any questions that you might have. Following this video, I'm going to be making another video that just kind of demonstrates how you actually use these rules to find missing sides of a 30, 60, 90 triangle. But for the purposes of this investigation, we're done. If you have any questions, again, ladies and gentlemen, by all means, please let me know what they are. Thanks for watching and take care. We'll see you guys later.